All right, guys, here we go. Let's get started. I didn't put a hashtag in there today. I'm sorry. Next time I'll put a hashtag, or I'll put hashtag no hashtag, and I can't even spell today. All right. Yeah, hashtag pumpkin pie. Okay, here we go, guys. Here we go. So, do you guys know what a water wheel is? Have you guys seen a water wheel before? Okay. So, suppose that a water wheel in the figure to the left rotates at 6 revolutions per minute. So, write that down somewhere. 6 revolutions per minute. 2 seconds. 2 seconds. 2 seconds after you start a stopwatch, because you have a stopwatch with you and you started it. Point P on the rim of the wheel is at its greatest height, 13 feet. Where's point P? So here it is. Here's point P, and it's rotating counterclockwise. So I guess its greatest height is right there. And let me make the y-axis here. So that's 13 feet above the surface of the water. So it's at its greatest height, 13 feet above the surface of the water. The center of the water wheel is 6 feet above the surface. 6 feet. And then here, if that's 6 feet and the radius is 7 feet, then this has to be -1. Okay. Are we okay so far, guys? We haven't done anything crazy, right? Okay. Sketch the graph of D, or the function of time t, in seconds since you started the stopwatch. Okay, we can do that. So it's just pretty much the same thing here. So I'm going to draw a y-axis again. There's my y-axis. And I'm going to make a high, not to scale. I'm going to try to make it perfect, but not to scale. The high is 13 feet, so there's 13 feet. And then, let's see, I'm going to make my x-axis right here. That's the x-axis, or the t-axis. And then I'm going to say, here's -1 foot. And then right smack in the middle, like right there, that's 6 feet. Are we still okay, guys? Does everyone see how I got the high, the low, and the middle? Okay. Next, I know that point P is at a maximum at 2 seconds after you start the stopwatch. Do you guys see that? So I'm going to say that this is 2 right here. I'm going to go, this is 2. I'm going to put a point at the max. So go to 213 and put a point at the max at 2 seconds. Did everyone do that? Okay. If I am doing 6 revolutions every minute, how long does it take to do 1 revolution in seconds? Well, there's 60 seconds in a minute. So 1 revolution in 10 seconds. Does everyone see how we got that? I'll repeat it again. Guys, you're doing 6 revolutions in 1 minute. And 1 minute, there's 60 seconds. So if you're doing 6 revolutions in 60 seconds, that means you're doing 1 revolution every 10 seconds. Does that make sense, guys?
Yes.
All right, perfect. So I think we're all in business. So here we go. I'm going to move 10 seconds from 2, so that's at 12, and I'm going to put another high point. So I'm going to make 12 like right here. I'm going to say 12 is right there. Put a point at 12, 13. Does everyone see how I got that? I'm going to move another 10 seconds, try to keep it equal distance, or try to make them the same. And I'm going to say at 22 seconds, I'm at another high point. I'm going to go another 10, so I'm going to say 32. And I'm going to do another high point. And I'm going to do one more, 42, and another high point. Bless you. Does everyone know how I got those points? Okay. All right. In between your 2 peaks, you have a min, right? In between the 2 peaks, you have a minimum. So right smack in the middle, between 2 and 12, you have a minimum. So right there. That happens at 7. Just add 5 to 2 or subtract 5 from 12. Chop, why did you do 5? Because the period's 10, so go half of that. Or you can also do 12 plus 2, that's 14, divided by 2 is 7. Whichever you think is easiest. And I'm just going to keep going plus 10. So 7 plus 10 is 17 right here. At 17, I'm going to put a point right like that. See? At 27, bam, negative 1. And then finally 37, negative 1. We're okay so far, guys? All right, here we go. Between your max and your min, you have a point of inflection. So between the 2 and the 7, so I'm going to add 2.5 to the 2, so that's 4.5. So at 4.5, put a point on your midline. Because point of inflections happen at the midline. Cool or not cool? Cool. Same thing with the next one after 7, 8, 9. So at 9.5, put a point right on the midline. And then the rest, I'm not going to put the X scale or the T scale. I'm just going to wing it. I'm just going to look. All right, we're done, guys. Wherever you have max, make them like a bowl upside down. Wherever you have mins, make them like a bowl there. Aim them towards your points of inflections. Well, it's not perfect, but that's fine. I feel like my scale is not really good, but that's fine. And not to scale. And there it is, guys. How do you feel? So the big theme here is knowing how to graph and knowing how to get an equation, which we need some work. According to you don't need any work, but according to our last quiz. Don't worry, I'll pass it back. I just haven't graded everyone's, and there's still one person that's missing that hasn't taken the quiz. I don't feel like creating a new quiz, so I'm not going to give them back until that person takes it. Because once I pass it back, you can't take it anymore. You know what I mean? All right. Are we still okay? All right. Here we go. Let's go to letter B. It says, assuming that D is the sinusoidal function of time, write our particular equation, confirmed by graphing that the equation gives you the graph you sketched in part A. All right. What do you want to do for, what type of sinusoid do you want to use? Cosine or sine? Cosine. Yeah, that's probably the best one for this one. So I'm going to write, it does say the letter D here. So right, D equals A cosine B parenthesis. And I guess it should be T minus C because it's time. But if you squint your head or you move your head a little bit, that X looks like a T. X minus C close plus capital D. Okay, I'm going to go down the alphabet. A. What's the difference between 13 and 6? That's your A. See? Your B. B is 2 pi divided by period. I have a peak at 2 and I have a peak at 12. So the period is? No, not cough. Yeah, 10. Sorry, guys. Some of you didn't catch that, but that's okay. What's 2 pi divided by 10? Pi over 5. Yeah, there you go. C. If I use a peak, what's my C? Yeah, 2 to the right. You don't have to say 2 to the right. You can just say 2. And then the midline D is 6. How do we feel? All right, here it is, guys. Here's my equation. D equals, if you write Y, that's fine. D equals 7 cosine, open parenthesis, pi over 5, open parenthesis, x minus 2, close, plus 6. This is what I'm going to write on my calculator. So it does say, confirmed by graphing that the equation gives you the graph you sketched in part A. So insert this into Y1 of your calculator. So here you go. I'm going to take my calculator, and I'm going to go to Y1, and I'm going to type in, what am I going to type in? 7 cosine alpha y equals, to get that little fraction there. You don't have to type that little fraction, but it'd be nice. Pi over 5. And then I move to the right, and then I go open parenthesis, x minus 2, close. Notice I put a minus. Some of you guys are putting plus. It's a minus. And then what's my midline? Plus 6. Okay. Don't push graph yet. Don't push graph yet. Click window. Let's see. X min 0, X max 45. So type it in, guys. Type it in. Practice, guys. Practice. 0, 45. X scale, you can make it go by 5. Y min. Well, let's see. The smallest I have is -1, so let's go a little bit below that, like -3. Y max. My biggest is 13, so let's go like to 15. And Y scale, that one's fine by 1. So there it is. So here's my Y equals, and here's my window. And I listened to you guys. You guys said that you guys want me to slow down, so there I am. I'm slowing down. Are we okay? All right. Push graph. My calculator is a lot faster than your calculator, so yours is not going to go that fast. That's because it is a computer, right? You have a, it's a processor. It doesn't have much power. Okay. How do you feel? All right, here we go, guys. I'm going to push the trace button. Trace, and I'm just going to verify. What am I going to verify? I'm going to verify these 3 right here. 2, 4.5, and 7. I'm going to check my high. I'm going to check my midpoint, and I'm going to check my low. So I'm going to push trace, 2. I already pushed trace. Now I got to push 2. Enter. And there it is, 13. Do I have so it's correct so far. Now I'm going to push 4. I already pushed trace, so now you can just put numbers. You can just push numbers. 4.5. Yep, there I am in my midline. 6. And what was I going to check next? The low one at 7. So 7. Enter. And there it is, -1. Click on window. Does your window look like this window? Let me see. That should be good enough. There you go. Want to help Kenny? Are we having a good time? Are you not entertained? You're not entertained? Come on, Tupac. Yeah, it is. It is a quote. It's from The Gladiator. Yeah. I love that movie. No, I do. You know what I love more, though? That sandwich you had. While I was doing this, I was like, you were like, "Arr, arr," and I'm like, man, that looks so good. I love food. Okay. Hello, parents, if you're watching right now. This is YWLA, 7th period. Okay. Give me a thumbs up, please. Huh? I didn't dog you guys. Oh. You guys ready? All right, here we go. When I push graph, I want you guys to know the context of this graph, guys, because this graph means something. So if you're below the x-axis, that means that point is underwater. Cool? And you read the graph left to right. So it's literally like if you have a point right here, it's moving down, and then it's moving up, and then it's moving down. If this graph is increasing, point P is moving up. If this graph is decreasing, point P is moving down. That makes sense? Okay. So let's answer the questions. Let's go to letter C. It says, how high above or below the water surface will point P be at the time t equals 17.5 seconds? At that time, will it be going up or down? So they asked me 2 questions. Where am I at? And is it moving up or down? So look, guys, you don't have to do anything. Type your calculator, push trace, and push 17. Did it say 17.5? Push 17.5 and push enter. Am I above water or am I below the surface? I'm below the surface because notice it says -0.657. And it's kind of hard to tell, but does it look like you're moving up or you're moving down? Yeah, you're moving up. If you can't tell, do this. Push zoom and push the number 2 in. Zoom in and then push enter. I noticed that it changed my... Okay, see how it changed? That's not your answer. Notice that it changed your X value, 17.55. You push trace again and just push 17.5. 17.5, enter. There it is. That's my right Y value. And now you can see that it's moving up. Do you guys see that? So I'm gonna go back to my little thing and I'm gonna say point P at t equals 17.5 seconds is below the water surface. Is below the water surface. You can say H2O or HOH, right? Two hydrogens and an oxygen is water. What, you thought chemistry was going to go away? No, chemistry doesn't go away. Below the water surface. There it is. So I answered the first part. Now, at what time will it be going? At that time, will it be going up or down? So I'm going to say at t equals 17.5 seconds, comma, point P is moving. What direction is it moving? Up. There it is. We answered the full question. How do we feel? Yeah, make sure you practice, guys. We're almost done, guys. Don't worry. We're almost there. Letter D. At what positive time t was point P first emerging from the water? Okay, so I'm going to go back to my graph. I'm going to zoom out. Zoom to 3 out. And I notice, no, this is no bueno. So I'm going to click on window again, and I'm just going to reformat it again. 0 to 40. I guess that's fine. Negative 3 to 15. That's what we had it initially, I think. And there, I'm just going to push graph again, and there it is. There's my graph again. So when am I first emerging? I am looking, not when I first cross the x-axis, but when I first get out of the x-axis. I guess this one right here, the one that's moving up. Does that make sense, guys? So there's a button. Remember, okay. So let me go ahead and I don't want you to be a robot. The x-axis has a y value of 0. And again, that's the mirror. Yeah, I'm gonna write. Okay, I'll stop. Don't give me a thumbs down. I can assure you I'm not writing a demerit for yawning. When I cross the x-axis, the y value is 0. Yes or no? So notice, look, push the calculate button. So you push second, calculate. Which one of those will calculate where the y value is 0? Number 2. It literally says 0. Do you guys see that? So you push number 2, and then when you do that, it says, where do you want me to look? It says left bound. So I want you to look. So you just push. You can actually type a number in, but I want you to look. There's my little cursor. I want you to look between here. So you just cross it, push enter, and then where's my right bound? Where do you want me to look? Between what and what? And I'm going to pass it. See, I'm going to pass it a little bit. I'm going to push enter. And now look, it gives you a nice little interval. So it's going to check between there and there. And if you have several, it says the word guess. If you have several, you scroll to the one that you want. But I only have one, right? So you don't have to do anything. You can just push enter. Push enter. And voila, look where it says 0 at 7.8611. So make sure you practice, guys. So that's the time that you are first emerging from the water. So I'm right. Point P is first emerging from the water at time equals, I already forgot it, 7.8611. 7.8611 seconds. Do you guys like these type of questions? Isn't that kind of cool because they're application? In a little bit, we're going to be doing sunspots. It's going to be so cool because sunspots is like sinusoidal for those that like to stare into space and let your mind wander. Okay, well, not that you probably can't stare at the sun for too long because, okay, LOL. All right. No, don't. I'm not liable for anyone losing their eyesight. Don't look at the sun. All right, here we go. You guys ready? So you're an engineer. You, being a super awesome engineer, Fiesta, Texas, hires you to build a portion of a roller coaster track in the shape of a sinusoid, just for a portion. And let's see. Check out the picture to the right. You have been hired to calculate the length of the horizontal and vertical support beams. Okay. Let's see what letter A says. The high and low points of the track are separated by 50 meters horizontally and 30 meters vertically. All right, there's a visual. There's a visual, guys. 50 meters horizontally, 30 meters vertically. The low point is 3 meters below the ground. So there it is. So this low point is 3 meters below the ground. Let y be the distance in meters. A point on the track is above the ground. Okay, so that's my y. Let x be the horizontal distance in meters, a point on the track from the high point. Okay, well, the high point starts at 0. Find a particular equation for y as a function of x. Okay. the best one to use is probably cosine, y cosine, because I have a high point right on the y-axis. Y equals A cosine, open parenthesis, B, x minus c, close, plus d. Are we okay so far? All right. Here's how I would do it. I'm not telling you that you have to do it my way. You can do it whatever you think is easiest, right? Whatever you think is easiest. A equals, well, I know the distance from high to low is 30. So if the distance from the highest to the lowest is 30, then A must be 15. Does that make sense? Okay. The B is 2 pi divided by period. Well, from high to low, this is 50% of a cycle. 50% of a cycle. You're not quite, a full cycle is the period. You're not quite, you haven't done a full cycle yet. So if 50% of my cycle is 50 meters, that means my period has to be 100 meters, twice that. Does that make sense to you guys? Okay, so 2 pi over 100 is pi over 50. And I'm going to put it right here, 100 meters is period. All right, the C. Because I'm using cosine, the C is 0. Because I have a peak right on the y-axis. Does that make sense, Fred Durst? Okay. The midline, the D. Well, let's see. You can do it one of two ways. You can either, you already know the amplitude is 15, so let's see. Down here, that's -3. And if I go up 30, way up here, that's 27. So you can do max plus min divided by 2. That's not the only way. That's just one way. 27 plus -3 divided by 2. And you get 27 plus -3 is 24. 24 divided by 2 is... Uh-oh, not everyone at the same time. Yeah, 12. Do you guys see how we did it? How did I get 27? That's a good question. Thank you, miss. So I got 27 because right here they told me that the low point is 3 meters below the ground. So because this is -3 right here, this is -3. Remember, this is 30 meters. So from -3, I'm going to go up 30, and I got 27. Does that make sense? So 27 plus -3 divided by 2. Any questions, guys? Hit me. We good? For sure? Okay. All right. I think I got everything, guys. I think we're good. I don't see any issues. Look, you can also make sure, look, 12 plus 15. Yep, 12 plus 15 is 27. 12 minus 15. Yep, 12 minus 15 is also -3. Everything works. Here it is. Here's my equation. Y equals A, 15, cosine, open parenthesis, pi over 50. Ask me, guys. Ask me. Oh, we're good. Okay, you don't need a parenthesis, x minus 0. You can just type x like that. Plus 12. It looks clean. There it is. How do we feel, guys? We feel good? Okay. Letter B. Y'all ready? The vertical support beams are spaced out 2 meters apart. That means these beams right here, guys, are 2 meters apart. This one is at x equals 0. This one right here is x equals 2. This one here is x equals 4, x equals 6, so on and so forth. I don't think it's to scale, by the way, because I don't think, or it might be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 28, 30, 32, 34, 36, 38. Actually, it might. It actually might. Wow. I'm impressive. They actually did it accurate. Make a table of values. So it says the vertical support beams are spaced 2 meters apart, starting at the high point and ending just before the track goes below the ground. Make a table of values of the length of the beams. All right, here we go. I'm going to write X, and I'm going to write vertical beam length. This is in meters. I know the first one, 0. At x equals 0, what is the length of this beam right here in purple or in blue? 27. I know that one. Without doing any calculations, I know that one's 27. I don't know the one at 2. I don't know the one at 4. I don't know that one at 6. Let's go all the way to 8. Dot, dot, dot. And according to this drawing, I think I went all the way to 38. That might actually be accurate. So it says, remember, it's before the track goes below the ground. So that's where, so I'm going to type, what am I going to do? I'm going to type this into Y1 of my calculator. So take your calculator. So let me take my calculator. And I'm going to go to Y equals. I'm going to clear Y1. And I'm going to type my new equation. 15 cosine alpha y equals, enter, pi over 50. Do you think Bad Bunny knows this? Yeah, he probably does, right? Yeah, because Bad Bunny probably had to take pre-cal. Plus 12. You know what would be cool? A cool halftime show for Super Bowl? If like Bad Bunny just did like math. Like let me. Oh, dang. Okay, here we go. Did everyone type this into Y1? Okay, type it into Y1 or wherever, whatever type of expression you got. We're not going to look at a graph. We're going to look at a table. Do you see up there how it tells you table where it says the graph button? So push the second and then push that graph button and look, there's a table. Are you shocked that at 0 it says 27? No, we're not shocked. And then go to 2 and then type 26.882. 26.882. Then go to 4 and type in 26.529. Okay. I wasn't going to show you guys this, but I'll show you guys this because I think you guys can do this really fast. All right. You see how you have all these numbers that you don't want. You don't want the 1, you don't want the 3, you don't want the 5. You want to know how to tell the calculator to just give you the even ones? You see where it says the button, you see where it says table set? Right where it says window? So you push second table set. See, it tells you that it starts at 0, and then it tells you that it says this little triangle with the table, that's the change in table, changing by 1. If you wanted to just have the even ones, I would just put my change in table to be by what? By 2. Do you guys see that? And now look, when you push enter, and then look, when you push table, OMG, these are all the values I want. Isn't that cool? Wow. Okay, sorry. That's not like a cat, right? Okay, meow. Okay, I'll stop. I love cats. But if you guys are haters, you don't like cats. Oh, okay. Yeah. I love cats. Be nice to cats, guys. All right, here we go. Oh, yeah. I love cats. 0, 2, 4, 6, 8. I feel like a cheer squad, right? Like 2, 4, 6, 8. Who do we appreciate? No? Okay. So give me the 6 one. What is it at 6? 927? 947. What is it at 8? 145? Okay, give me all the way until it goes below ground. So right before it goes below ground. So let's see. Yeah, I think that graph was accurate, guys. So 34, 36, 38. And then right at 40, it goes below ground. So 34, 36, 38. That graph is actually accurate. Yeah, I counted 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Wow. Whoever did that little was good. What is it at 34? What is it? Tell me again, because I didn't hear it. 3.966 626. 626. What is it at 36? 4386. What is it at 38? 065 what? 55. 0655. And then at 40 it says negative. So that's it. That's all. Those are all my vertical beams. And of course this dot 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 means that there's numbers here, right? We didn't write all those down. We don't have to write every single one down. Just cool or not cool? All right, let's go to the next one. Sorry that the formatting's kind of funny. That continue should have been up there, but that's fine. Now it says the horizontal beams are spaced 2 meters. I'll slow down because I see some of you guys. Okay. The horizontal beams are spaced 2 meters apart, starting at ground level, not stared. Starting at ground level and ending just below the high point. Make a table of values of horizontal beam length. So now we're doing the horizontal beam length. So I'm going to write Y and horizontal beam length in meters. We're almost done, guys. 0, 2, 4, 6, 8, ... And I know, because these are horizontal beam lengths, so focus right here real quick. I know that the biggest I can go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Yeah, man, this guy's good. Whoever drew this, or lady, whoever drew this graph, it's accurate actually. I know that the highest I can go is 27, but they're 2 meters apart. So so the highest I'm gonna go, it's not 27. I'm gonna write what? 20. Yeah, 26, 24, 26. There is no 28. Does that make sense? All right. I do not know what the horizontal beam length is at 0, but I know that it's smaller than 40. Chop, how do you know that? Look, guys, I know it's smaller than 40. Everyone, can you guys see from where I'm at? Here's my horizontal beam length, the one on ground level. All the way over there. Well, that was already 38. So I know it's a number between 38 and 40. Do you guys see that? This one at ground level. I know that one's a number between 38 and 40. I don't know what number that is, but I know it's between 38 and 40. We're going to find it. So here's what we're going to do. We're going to solve for x on the equation. So I got a lot of white space here. So write y equals, and I already forgot the equation. What was it? 15. Yeah, hook me up. 15 cosine pi over 50 x. Oh yeah, just x. So let me make it clean. So, I mean, you can put parentheses x, but just one set of parentheses. Was it plus 12? Okay, we're solving for x, guys. So now it's arithmetic. All you're doing is algebra, and that's why we took algebra 1 and algebra 2. So first move. What's my first move? I'm trying to solve for x. Minus 12. So right. I'm going to write this expression on the left-hand side and the y minus 12 on the right-hand side. So here we go. I have 15 cosine pi over 50x, close it, equals y minus 12. Did I confuse anyone? Okay. Get up to here, guys. What's my next move? Yeah, divide by 15. Divide by 15 both sides. Cosine pi over 50x equals y minus 12 over 15. And I'll slow down. What's my next move? Inverse cosine. Look at you guys. Nerds. Pi over 50x equals arc cosine y minus 12 over 15. Close it. Child, you didn't put plus minus. I don't care about the negatives. We just want positive values. I hope no one gets offended when I call you guys nerds. I mean that with love. I'm a nerd. We're all nerds. Okay. Yeah, if you get offended, please let me know, so I won't call you that. Because when I say it, I mean it with nothing but love. All right. No more fighting. All right, here we go. How do I get x by itself? Yeah, multiply by the reciprocal. You can say divide by power 50, but I think it looks cleaner to say multiply by the reciprocal. Does that make sense to you guys? So I think that looks cleaner to me. So here it is. X equals 50 over pi, arc cosine, that's a negative 1 there, y minus 12 over 15. Child, how are we going to find this out? This says x equals, and my calculator only says y equals. We're going to do a hack. It's not a bad hack. It's not an extreme hack. So here's your hack. Don't delete y1 because we're going to need it later on. So here's my hack, and I'm going to put it in quotes. It's not even an extreme hack. You're going to go to y2, and you're going to type 50 over pi, arc cosine of x minus 12 over 15. Close it. So here it is. I'm going to go to my calculator, and I'm going to go y equals. Do you guys know how to turn off Y1? Let me show you guys. You hover over the Y1, the equal button, and you push enter. And then look, it turns it off. It's because we're going to need Y1 eventually. That's why I left it there. All right, here we go. I'm going to type in 50 over pi. So I'm going to push a little fraction thingy. 50 over pi. And then we're going to go second arc cosine. And then I'm going to do the fraction thingy again. Put the fraction thingy or else, or use parentheses because you don't want to mess up here. And I'm going to put y minus 12 in the top, so x minus 12. X minus 12. And I'm going to put 15 on the bottom of that. 15. And I'm going to close it. Y'all ready? All right, here we go. Second table. Top, it says error. Scroll up to 0. Are you surprised that at 0 it says 39.758? No, we're not surprised. 39.758. That's meters. 0. At 2, what is it at 2? 36.614. 36.614. Someone hook me up with the 4 one. Bless you. What is it at 4? 33. Bless you squared. 33 point what? 953? 953. What is it at 6? 5 1 what? 549. Got it. What is it at 8? 296. Okay. Dot dot dot. What is it at 24? 242. Where is it at 26? 844. I can't hear you, miss. 844, my bad. And then notice, are you shocked that at 28 it says error? No, you're not shocked because it only goes to 27 meters high. There is no horizontal beams at 28, at y equals 28. Cool, right? Are you not entertained? Okay, I hope so. All right. I'm going to stop it here. All right, so letter D says, hey guys, you must know how much support beam materials to order in the most time-efficient way. Find the total length of the vertical beams and the total length of the horizontal beams. All right, so how are we going to do this? Well, first and foremost, type in this equation into Y1 because it's been a while now. So type that into Y1 and then type this equation into Y2. This equation. So y equals y1 and 15 cosine pi over 50 plus 12. And then on Y2, I'm going to type in, what am I going to type in? 50 over pi, arc cosine. Y minus 12 over 15, so the x minus 12. So all right. Oh, sorry. You guys have that? Okay. So let's try something out. So first, let's understand how this calculator works. We know that if I go to table, that Y1, so someone add these first, I guess this first two. The one at 27 plus 26.882. Job, why are you making us do that? Well, let's see what that is. So Y1, so I'm going to push alpha trace Y1, And if I push 0, that should tell us 27. See? So alpha trace. So now that I know that that calculator can do that, well, that's just like saying f of x, right? Or f of 0. So that plus alpha trace y1 at 2. So what am I doing right now? I'm just adding the first two beams. And if you wanted to, you could do this all the way until you got to, let me see, which one? All the way until you got to number 38. And yeah, you can add them up like that. So the first two is 53.881. I want to see if I can do that with my sigma notation. So I'm going to go math, and I'm going to go sum. Where are you? I don't know why it took me so long to look at that. And I'm going to say from x equals, so there's the first one, but we're going to count this as like my zeros term. I know that may not make sense to you. 0, and I'm going to put a 1 here. Chop, what are you doing? And notice that it says y0 and y2. So in order to do that, I'm going to go alpha trace y1, because all this is doing is summing, and I'm going to make it an odd 2x. So let me see if you guys can figure out the logic here. And you'll get better with this, especially if you start programming. So what I'm telling the calculator here is to start at x equals 0, and this only executes integers. So I'm going to start at x equals 0, I'm going to go y1, what's 2 times 0? 0, so there's this one right here. And then it's going to go to the next term, y1, it's going to plug in a 1, plus y1, what's 2 times 1? 2. So if this is correct, this is not the final form, this is just a test. If I'm correct, if we're correct, this should give me this exact number, digit per digit. So let's see if that's true. I'm going to push enter, and voila, it's true. So now the logic, I need to do this from 0 all the way. You're not going to say 28. Or 38. You're not going to say 38. You're going to say 38 divided by 2. What's 38 divided by 2? 16. No, 16 is 32. 19. 19 is 38. So I'm going to go from 0 to 19. So I'm going to go 0 to 19. And that should add, it's going to go 0, 2, 4, 6, 8, 10, 12, 14, 16, all the way until 38. Does that make sense? What's up, miss? I don't know where it's at, miss. I'm sure it's somewhere. I'm sure someone has it. Bam. And there it is. That's the number, guys. 323.63697. Do you guys see what we did? Cool or not cool? Do you guys think you guys can repeat this for the... This is a horizontal horizontal beam length. Wait, no. These are the vertical one. This is the vertical beam length. So you guys guide me. How do I do the horizontal beam length? How do I do it, Ms. Pearsall? Well, I want to do the same thing, but with the vertical beam. So what do I do? Math, 0, x equals 0, all the way to, I don't know. Let's see. It goes all the way to 26, but you're not going to put 26 in there. You're going to put what? 13. 13, because 13 plus 13 is 26. And then I have the vertical beams on y2. No, what do you mean sure? Look, there it is on y2. So how do I put y2 in there? Alpha trace number 2, y2. And then I'm going to put parenthesis. And what do I type inside the parenthesis? 2x, because they're spaced by 2. Close, and there it is. And hopefully you guys are getting better at coding and doing arithmetic. And there it is, guys. See, that wasn't so bad. Was that bad? So 330.844 meters. So what was my horizontal? Horizontal. That's the one that we just did. Horizontal beam length. What is it? 330 point. Come on, guys, help me out. 0.844. meters. What was the vertical beam length? 323 point what? 636. 637. Meters. And if for some reason they ask you total, you can just scroll up. Enter plus enter. 654.481 meters of total beam length. So can you guys do that if you guys are engineers? Yeah. How are we feeling? Okay. I think we're good now.